Hello dear students, welcome to the video class. Today we are going to take up the first chapter of our syllabus, chapter number 1, Chemical Reaction and Equation. In this chapter we are going to study about the chemical reaction, the characteristic of chemical equation, what are the different types of chemical equation and what are the different types of chemical reactions. So first let us see what is a chemical reaction. In the nature and in our surrounding, different types of changes used to take place. These changes can be divided into two types depending upon their characteristics. It may be a physical change or it may be a chemical change. Physical changes are the type of change in which new substances are not formed, while chemical changes are the type of change where new type of substances are formed with different type of qualities. These chemical changes, we call them as chemical reactions also. There are certain characteristics that are obtained or that are observed during a chemical reactions. Some of the important characteristics of a chemical reactions are the formation of new substance, change in the color, absorption or evolution of energy, especially in the form of heat. Number 4, evolution of gas. These are some of the important or common characteristics that we observe during a chemical reaction. In a chemical reaction, one of these characteristics may be observed, or in some of the chemical reactions, all these characteristics may be observed. So, these are some of the important characteristics of a chemical reactions. Now, let us see about the chemical equation. Chemical equation is a short representation of a chemical reaction that is taking place in our surrounding. There are different types of chemical equations. First one, let us see. The first one is known as the word equation. To understand this word equation, let us take up one example. Suppose, let us say, magnesium burn in air in order to form magnesium oxide. So during this reaction, the things that are undergoing the reactions are magnesium and oxygen. So this magnesium and oxygen which are undergoing or which are performing or taking part in a chemical equation, we call them as the reactants. While the magnesium oxide which is formed during this reaction, we call them as product. Let us see. So if we represent the reactants and the product with the help of the word representing that elements or representing that substance, such type of equation we call it as a word equation. So while writing a chemical equation, the reactants and the product, they are separated by the help of an arrow pointing towards the product side or pointing towards the right hand side. So this is the way how a word equation can be represented. Now let us see the next type of chemical equation, which is known as the skeleton equation. In the skeleton equation, the reactants and the products will be represented by the help of the formulas representing that element or representing that compound. Here, the number of atoms of each and every element that is used in these equations are not equal, but the formula should be represented correctly. So now let us try to represent the same equation that we studied during the word equation in the form of skeleton equation. Magnesium, the formula is represented by Mg. Oxygen is represented by O2, and magnesium oxide, the formula is represented by MgO. In this equation, the formulas of every substances are represented correctly, but when we count the number of atoms of each and every element, they are not equal in the reactant and the product side. Let us see. Magnesium, in the reactant side, only one atom is present. In the product side also, only one atom is present. But in case of oxygen, in the reactant side, the oxygen is having two atoms. while in the product side only one atom of oxygen is present. So such type of equation in which the substances, the reactants and the products are represented by the help of the formula, but without matching the number of atoms in the reactant and the product side, such type of equation we call it as a skeleton equation. Now let us see the third type of equation, which is the most important type of equation. The third type of equation is known as the balanced chemical equation. So let us see what is the balanced chemical equation by the help of an example. Let us take the same equation. Magnesium plus oxygen gives magnesium oxide. So a balanced chemical equation is the type of equation in which the number of atoms of each and every element are equal or same in both the reactant and the product side. So in this equation, this is a skeleton equation. Here see, let us count the number of atoms of magnesium and oxygen used in this equation. In the reactant side, the number of magnesium atom is 1. Here also 1. For oxygen, the number of atoms is 2 in the reactant side, while in the product side, only 1 atom of oxygen is present. So in order to balance it, or in order to make it balance, I am going to make the number of oxygen here as 2 by putting a number in front, that is 2. The 2 that I put here in front of this magnesium oxide will be for both magnesium and oxygen. So when I put here 2, the number of oxygen atoms become balanced or same, but the number of magnesium atoms is not equal. In the product side, the number of magnesium atom is 2, while in the reactant side, it is only 1. So to make it balanced, I put here 2 in front of this magnesium. Now, in this equation, both the oxygen and the magnesium have equal number in the reactant and the product side. Such type of equation, we call it as a balanced chemical equation. Now let us see how to balance a chemical equation by taking an example. Now here, an example is given on the board. In this equation, iron is reacted with water to form iron oxide and hydrogen gas. So in order to balance this, we are first going to write the elements that are used in this equation one by one. The elements are iron, hydrogen and oxygen. After this, we are going to write the number of atoms of these elements in the reactant and the product side separately. So for this iron, in the reactant side, 1 atom is used, and in the product side, 3 atoms of iron is formed. For hydrogen, 2 atoms of hydrogen is used in the reactant side. In the product side, 2 atoms of hydrogen are formed. For oxygen, there is only 1 atom of oxygen in the reactant side, but in the product side, there are 4 atoms of oxygen. So in this way, we have written down the number of atoms of each and every element in the reactant and the product side. So let us see. When we compare the number of atoms of these elements in the reactant and the product side, we came to know that hydrogen, the number of hydrogen atoms in both the reactant and product side are equal. So the hydrogen is balanced. After that, there is a need to balance iron and oxygen. So the first and foremost important thing that we have to do during a chemical balancing of chemical equation is selecting a proper element to balance first. So the element whose number of atom in one of the side is odd number, in another side is even number, select that element first. So here in case of the iron, in both the side, reactant and the product side, both the numbers are odd numbers. For oxygen, in one side it is odd, in another side it is even. So let us first select this oxygen to balance. Another important thing is that the element which is remaining alone separately, that element should be balanced at the end. So now let us try to balance this oxygen. In order to balance it, we are going to make this 1 into 4. So for that, in front of this water, I added 4. So when I add 4, the number of oxygen atom becomes 4. Now, after adding this 4, hydrogen becomes 8. The number that is present in front and the number of atoms present in that molecule should be multiplied. So hydrogen becomes 8. 4 2s are 8. So we are going to make this 2 into 8 so that the number of hydrogen will become balanced. So for that, I am going to add here 4. Now hydrogen also and oxygen also is balanced. Now the only element that is left to balance is iron. Iron, in the reactant side, only 1 atom is present. In the product side, 3 atoms are present. So in order to make this number of atoms of iron in the reactant side 3, I am going to put here 3. So after balancing, you have to again count the number of atoms of every element, whether they are same in the reactant and the product side or not. So for iron, the number of atoms in the reactant side is 3, in the product side also is 3. For hydrogen, the number of atoms in the reactant side is 8, in the product side also it is 8. For oxygen, it is 4, here also is 4. So now the equation is balanced. So when you give an example in the form of a chemical equation, it should be always in the form of a balanced chemical equation. You have to keep this one in your mind. So these are the things that we studied today. In the next class, we are going to take up the remaining portion of this chapter. So for today, let us wind up here, dear students. Thank you.